Hi, and welcome to the second video for section 3.4. This is the second of two videos. In video 1, we looked at the polynomial, it was degree 3, had 3 terms in it, and we had to find the possible roots. That one was difficult enough as it was, but if we get into even bigger polynomials, it can start to get pretty messy. And that's what we're going to do here. So if there's a more complicated polynomial p of x, and like I said, in video 1, that was complicated enough. So, of course, they can get a lot more messy. If we have those ones that are a lot more messy, we're going to do 3 things. First, we're going to list the possible zeros. 2, once we get all those values, because the last example we had what? We had 4 possible roots. That was at the end of video 1. Depending what our p and q's are, we could end up with a whole bunch of possibilities. And if it's like a degree 5 polynomial, I don't want to be calculating all those numbers. So what we're going to do instead, once we have those possible zeros, we're going to use synthetic division until we find one that has a remainder 0. Remember when we do synthetic division, if that last number comes out to be 0, we know that that value was one of the roots. And now we have a new polynomial that we can start doing synthetic division off that. We're not going to go back to the original, we're just going to keep on going. And that's what step 3 is, repeat. So use synthetic division, find a root, and then repeat it. So let's look at this example. We want to factor the polynomial p of x is equal to 2x to the third plus x squared minus 13x plus 6. So let's list all of our possible zeros first. So we have what? With this plus 6 here, we get either plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are all the factors of 6. And how about the 2? That's plus or minus 1 or plus or minus 2. So all the possible zeros, remember this is our p, this is our q. So it's going to be what? It's going to be plus or minus 1 over 1, which is 1. Plus or minus 2 over 1, which is 2. So I'm just doing 1 over 1, 2 over 1, 3 over 1, 6 over 1. So plus or minus 3, plus or minus 6. Now we have the 1, now we have the p-values over 2. So plus or minus a half, plus or minus 2 over 2. 2 divided by 2 is 1, that's already taken care of here. And then plus or minus 3 halves. And then plus or minus 6 over 2. 6 divided by 2 is 3. That was already picked up in our first row. So I have 6 numbers, plus and minus, which is 12. I don't want to do remainder theorem with 12 different numbers. So what I'm going to do, let's also look at our sign change. So possible positive values. Well, what is our sign change? Positive, positive, negative changes once. Back to positive, change twice. So my possible positive roots are either 2, or if I deduct 2, 0. My p of minus x well, anywhere I have an odd degree, that's going to change. So this goes from plus 2 to minus 2x to the third. This stays the same, so plus x squared. This changes to positive, plus 13x. That stays plus 6. So I get what? Negative to positive, that's 1, and then it stays positive. So my possible negative roots is 1, and that's it. I can't go down by 2 and still have a possible value. So 1 possible negative, 1 possible 2 or 0 possible positives. So given that's the case, since I only have one possible negative root, I could really try to start using my negative values as my C value for the synthetic division. So let's try that. Let's list out our polynomial here. So we have what? 2, 1, negative 13, and 6. And the truth of the matter is, there's no guidelines or there's no rules saying start with this value or don't start with that one, start with this instead. You could start at plus 1, plus 2, plus 3, plus 6. See if any of those work. I would try to save the fractions till the end if you don't have to do those. And then maybe go back to the negatives, negative 1, negative 2, negative 3, negative 6 if you have to. There's no right or wrong starting point. I'm only picking negative 1 to start with because I know I have one possible negative root. So I'll just start with the negative values and see where that gets me. So if I plug in negative 1, by synthetic division, what do I get? Bring down the 2, multiply is negative 2. Add down, negative 2 plus 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 13 plus 1 is negative 12. I can already see this isn't going to work, right? Because negative 1 times negative 12 is plus 12. Add down is 18. It's a remainder of 18, so I know this one does not work. So how about negative 2? So what I have here, negative 1, negative 2, negative 3, negative 6. So I'll just go up to negative 2. That gives me what? 2, 1, negative 13, and 6. Bring down the 2, multiply is negative 4. Add them, negative 3. Negative 2 times negative 3 is positive 6. Add them, negative 7. Negative 2 times negative 7, positive 14. Add them, 20. Still not going to work. Let's go to negative 3. 2, 1, negative 13, 6. Bring down the 2. Multiply is negative 6. Add them is negative 5. Multiply these guys is 15. Negative 3 times negative 5, positive 15. Add them is 2. Negative 3 times 2 is negative 6. Add them 0. Bingo. There's one of my roots. Now, because this started as a degree 3 polynomial, this guy is really what? This is 2x squared minus 5x plus 2. So go ahead and try to factor this. So we get 2x and x. I need a negative 5, so I'm going to do minus 2 and minus 1. So now set these equal to 0. I get 2x minus 1 is 0. Let me move this up here so you can see it a little better. So bringing this up, I get 2x minus 1 is 0. So 2x is equal to 1. X equals 1/2. That's good, right? Because we knew plus or minus half might be one of the roots. And then lastly here, x minus 2 is 0. So x equals 2. Also positive. Notice we have two positives, which we knew we needed 2 or 0. We have one negative, which we knew from the start, one possible negative. So all the zeros, we want to factor this. Okay, yeah, so factor it. I got these as my zeros. So if those are my zeros, the factors would then be what? It would be x minus 1/2 times x minus 2 times x plus 3. So again, depending if it's asking for the zeros, these are the zeros. That's my value of C. If it's asking to factor it, if you're supposed to put it in binomial form, then it's the opposite of what we had for our numbers for 0. So that's that example there. Let's look at one more example. That'll wrap up video 2. I'm sorry, video 2 for this section, the last video for this section. And again, with this process, sometimes you'll get lucky. You'll hit that number right off the bat, and the numbers start falling into place for you. Other times, you might have to go through it a few times before you get that number you need. So for this example, let's find the zeros of p of x is equal to x to the fourth plus 6x to the third plus 7x squared minus 6x minus 8. So, our possible zeros are what? Well, if you want to try this, by all means go ahead. We did that last example. This is going to essentially be the same way. If you want to sort of get the groundwork laid and then do the synthetic division part, that's fine too. Start and stop as you feel the need. The good thing here, our coefficient of our highest degree term is 1. So we're really only worried then about the factors of this guy at the end, which is what? 8, which is 1, 2, 4, and 8. So our possible zeros are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. How about the possible positive zeros? How many of those do we have? Well, that's our sign change rule. We're at positive, 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 negative. Okay, it changed once, stayed negative. So we have only one possible positive root for this polynomial, which is great, right? Because my possibles are plus 1, plus 2, plus 4, plus 8. So if I do my synthetic division, as soon as I find one of the positive ones, I'm done. I know I can start trying my negative values. You can see, because this is a fourth degree polynomial, I don't really want to do the remainder theorem because these numbers are going to get real big in a hurry. So how about the possible negatives? Zeros. Well, that's if we change all the odd degree terms. So x to the fourth stays. This changes to negative. This is an x squared, so that stays the same. X changes to plus 6. Minus 8 stays. So we have what? How many sign changes? Positive and negative, that's one change. Back to positive, 2. Over to negative, 3. So the possible negative zeros are either 3 or 1. And we know that we need 4 total, so it's what? It's going to have to be 3 of these roots. So let's go ahead and start our synthetic division. So I'll start with positive 1. So my coefficients are what? 1, 6, 7, negative 6, negative 8. Make sure if it's got a negative sign, you bring it along. Make sure if there's a term missing, you put in a 0. Got to be careful of all those things as you're doing this. Synthetic division, bring down the 1, I get 1. 1 times 1 is 1. 6 times 1 is 7. 1 times 7 is 7. 7 times 7, 7 plus 7 is 14. 1 times 14 is 14. 14 minus 6 is 8. 1 times 8 is 8. Oh, perfect. Negative 8 plus 8 is 0. So that means my positive root, or my positive 0, is plus 1. Do I need to check 2, 4, and 8? No, because I only have one positive and I just found it, right? So now, like I said, don't start over. And this is where I see a lot of people get into trouble with these kind of problems. Is that now they're like, oh, now I have to find the negatives. Well, let me go back to the original one. You don't have to do that. Simplify your work. We already know this is our simplified polynomial. It was x to the fourth. So this is what? X to the third, 7x squared, plus 14x, plus 8. So just check your negative possible roots on that. We have what? We have negative 1 to start. And again, you can start with any. I'm just going to start with negative 1. Bring down the 1, you get negative 1. add them, you get 6. Multiply negative 6, add them, you get 8. Multiply these, negative 1 times 8 is negative 8. That's great again. Well, that worked out nicely for us. So, remainder 0, meaning negative 1, is also one of our roots. And again, sometimes this works out nice, sometimes, as you saw in the last problem, we had to go a few steps. So this started as our x to the 4th. Once we found remainder 0, this became x to the 3rd. We found another remainder 0, so this is my x squared. So this polynomial is really x squared plus 6x plus 8. Let's see if we can factor this one instead of having to do our synthetic division. And what do we get? We get x plus 4, x plus 2, meaning our other positive roots, other negative roots are what? X plus 4 is 0. X plus 2 is 0. So these are our factors, but we want the zeros. So that's x is equal to negative 4, x is equal to negative 2. So all of our zeros, the 4 different ones are positive 1, negative 4, negative 2, which falls into exactly what we expected. It has to be a 1, 2, 4, 8 plus or minus. Only one positive, 3 or 1 negative, which we know we need 4 total, so it's our 3 negatives. So that's it. That's the end of video 3.4. This might seem a little bit daunting. I promise you the more of these you do, it's like, oh, this is starting to get boring because it's the same process every time. It's find your possible zeros, all the pluses and minuses, P over Q. How many possible positive, how many possible negative based off the sign change rule. Use your synthetic division and you'll get quick with it as we kind of went through pretty quickly. Find the values and you're good to go. So come on back and we will look at video 3.5.